Welcome to Chapter 2 of Mechanics of Deformable Bodies. So dito pag-uusapan natin ang simple strain. So here is the outline of the topics. We have the topic 2.1, stress strain diagram, wherein dito pag-uusapan natin yung proportional limit, the elastic limit, elastic and plastic ranges, yield point, ultimate strength, modulus of resilience, modulus of toughness, working stress, allowable stress, factor of safety. And topic 2 is axial deformation. Topic 3, stiffness. Topic 4, shearing deformation. Topic 5, Poisson's ratio. Topic 6, biaxial deformation. Topic 7, triaxial deformation. Topic 8, a relationship between the modulus of elasticity, modulus of rigidity, and the Poisson's ratio. Topic 9, bulk modulus of elasticity or modulus of volume expansion. Topic 10, statically indeterminate members. And topic 11, thermal stress. So, pag-uusapan natin yung simple strain. Simple strain is also known as the unit deformation. A strain is the ratio of the change in length caused by the applied force to the original length. So we have the strain is equal to delta over L, wherein this delta here is the deformation. So kapag yung isang body subjected to axial stress, so halimbawa ito na to ay hinila natin, we apply the force P and this body is subjected to tension, meaning magkakaroon ng change in length. And this change in length here is referred to as the deformation delta. And this L is the original length. Since the unit of deformation is linear and the unit of the length is linear, so therefore this strain here is dimensionless. What is a stress strain diagram? So suppose that the material specimen be placed in the tension compression testing machine, or if sa school ninyo ay meron kayong universal testing machine, so the axial load is gradually increased in increments. The total elongation over the gauge length is measured at each increment of the load, and this is continued until failure of the specimen takes place. So knowing the original cross-sectional area and the length of the specimen, the normal stress sigma and the strain epsilon can be obtained. So ito yung mukha ng stress strain diagram. The graph of these quantities with the stress sigma along the y-axis and strain along the x-axis is called the stress strain diagram. The stress strain diagram differs in form for various materials. The diagram shown here is for the medium carbon structural steel. So, nakadepende yung mukha ng stress strain diagram sa material. Magkakaiba yung properties ng bawat material. So, shown here is the stress strain diagram of the medium carbon structural steel. So, we have the stress in the y-axis. We have the strain in the x-axis, and then here you have the proportional limit, the elastic limit, the yield point, the ultimate strength, and then here is the actual rupture strength, and we have here the rupture strength. Proportional limit, so this is denoted as P. Ito yun, part na to. From the origin to point P is called the proportional limit. So, galing dito sa point O hanggang doon sa point P, itong line na to ay tinatawag na proportional limit. The stress strain curve is straight line. The linear relationship between elongation and the axial force causing it was first noticed by Sir Robert Hooke in 1678. Kaya, meron tayong Hooke's law. So, ano yung Hooke's law? This linear relation between the elongation and the axial force causing it is called the Hooke's law. that within the proportional limit, the stress is directly proportional to strain. So we have stress is directly proportional to strain. Or in this sense, we have the stress is directly proportional to strain. In this case here is the proportionality constant, yung kung maalala natin sa algebra natin. So the constant of proportionality is called the modulus of elasticity. So this K here is equal to the Young's modulus of elasticity, or this is denoted as E, and is equal to the slope of the stress strain diagram from O to P. So we have the slope of the stress strain diagram. So ano yung, kasi kung makikita natin dito, we have the modulus of elasticity is equal to stress sigma over the strain epsilon, no? So we have here this stress is the rise, and this epsilon or the strain is the run. So we have the rise over run, so therefore the Young's modulus of elasticity is the slope of the stress strain diagram starting from point O up to the point P. Ano naman yung elastic limit? So, elastic limit is the limit beyond which the material will no longer go back to its original shape. So, balikan natin ditong sa proportional limit. Sa proportional limit, kapag yung stress ay applied, ay hanggang dito lang sa proportional limit ng material. So, ibig sabihin siya ay after i-release mo, no, yung load applied, siya ay babalik sa original niya na length. Pero, kapag dito, narating natin yung elastic limit, sabi dito, the elastic limit is the limit beyond which the material will no longer go back to its original shape when the load is removed. Or, it is the maximum stress that may be developed such that there is no permanent or residual deformation when the load is entirely removed. So, kapag narating niya itong elastic limit, ay hindi na babalik yung material sa original niya na shape. What is elastic and plastic ranges? The region in the stress strain diagram from point O to P is the elastic range. Yung region galing sa point O hanggang sa point P ay tinatawag nating elastic range, while the region from point P up to here at point R ay tinatawag naman natin plastic range. So what is a yield point? Yield point is a point at which the material will have an appreciable elongation or yielding without any increase in load. So halimbawa, nag-apply tayo ng load sa material and naabot niya na yung proportional limit. Then, nag-apply ng load and naabot niya na yung elastic limit. So, kung ito si load P, ay in-increase natin hanggang sa marating niya na yung elastic limit. Once na marating niya itong yield point natin, that's Y, kahit yung load mo ay constant na, hindi mo na siya i-increase yung load, ay patuloy na magkakaroon ng elongation yung material. What is ultimate strength? Ultimate strength is the maximum ordinate in the stress strain diagram. It is the ultimate strength or the tensile strength. Si ultimate strength, this is the maximum ordinate in the stress strain diagram. What is rupture strength? So rupture strength is the strength of material at rupture. This is also known as the breaking strength. So kapag yung material ay sinabject natin into loading, so tuloy-tuloy yung elongation niya, once na mag-break yung material, so that point of breaking ay tinatawag nating rupture strength. What is the modulus of resilience? The modulus of resilience is the work done on a unit volume of material as the force is gradually increased from O to P. Yung unit nito ay Newton meter per cubic meter. This may be calculated as the area under the stress strain curve from the origin up to the elastic limit, E. The shaded area in the figure is the resilience of the material. It is ability to absorb energy without creating a permanent distortion. The shaded area here from point O to point E is the modulus of resilience. The modulus of toughness naman is the work done on a unit volume of the material as force is gradually increased from point O up to point R. So unit is Newton meter per cubic meter. So this may be calculated as the area under the entire stress strain curve from O to R. So the toughness of the material is the ability to absorb energy without causing it to break. So yung area naman under the curve from point O to point R is the modulus of toughness. Anong pinagkaiba ng working stress sa allowable stress? And what is the factor of safety? So working stress is defined as the actual stress of the material under the given loading. So kung ano yung nire-resist na stress ng material. So halimbawa ikaw ay pumatong sa isang upuan. So basahin ko muna yung definition ng allowable stress. The maximum safe stress that a material can carry is termed as the allowable stress. The allowable stress should be limited to the values not exceeding the proportional limit. So however, since the proportional limit is difficult to determine accurately, the allowable stress is taken as either the yield point or the ultimate strength divided by the factor of safety. So, halimbawa itong upuan na to. Pasimplihin natin yung mga bagay-bagay. Itong upuan na to ay may capacity na magbuhat ng 90 kg na mass ng kahit anong bagay. So, tao na lang per se. So, kung ikaw ay may bigat na 65 kg, ibig sabihin, itong upuan na to ay magre-resist lang ng 65 kg. Why? Kasi sabi nga dun sa may third law of motion, diba? In every action, there is always an opposite and equal reaction. Ibig sabihin, itong force, itong stress na nire-resist ng upuan, given as the load. So, kung ikaw ay 65 kg, so ang upuan ay magre-resist lang ng 65 kg para mabuhat ka niya. Kung may pumatong dito na 50 kg, so 50 kg din yung i-resist niya. So, yun yung working stress. While the allowable stress is the capacity of the chair to hold the load. So, kung siya ay may capacity na 90, ibig sabihin, yun yung kaya niyang buhatin. Yung working stress ay kung ano lang yung actual na load na nakalagay sa kanya, yun lang yung nire-resist niya. Hindi naman pwede na ikaw ay 65 kg, tapos ito yung upuan na may capacity na 90 kg. So, magre-resist siya ng 90 kg. What will happen? So, kulang yung summation of forces vertical, so you have a positive value. So, ibig sabihin, so the excess between the 65 kg and the 90 kg ay yun yung magtutulak sa iyo pataas. So, ibig sabihin, tatalsikan na nun. 90 kg is the limit, no? So, what if yung nagpatong dito ay mas mataas sa 90 kg? So, ibig sabihin, masisira yung upuan, no? Okay. So, the ratio of the ultimate or yield strength to allowable strength is called the factor of safety. Ngayon, pag-uusapan naman natin yung axial deformation. In the linear portion of the stress-strain diagram, the stress is proportional to strain, that is given by the equation stress is equal to the modulus of elasticity multiplied by the strain, wherein this E here is the Young's modulus of elasticity, which serves as the proportionality constant. So, from the idea that the strain is equal to the deformation over the original length. So, we substitute that in our equation and we would have stress is equal to the modulus of elasticity multiplied by the deformation over the original length. And if we are going to express this in terms of the deformation, then we have here the deformation is equal to the stress multiplied by the length over the modulus of elasticity. And this is our equation in solving for the deformation given is the stress, the length, and the modulus of elasticity of the material. But since we know that stress is equal to force over area, then substituting that in our equation, and we would have the deformation is equal to PL over AE. So, para hindi natin makalimutan itong formula natin, if you want something to change, we always remember that poor lovers are everywhere. So we must remember that if we are going to use this formula, the load must be axial, the bar must have the uniform cross-sectional area, and the stress must not exceed the proportional limit. If, however, the cross-sectional area is not uniform, the axial deformation can be determined by considering a differential length and applying the integration. So we would have the formula from the formula of the deformation is equal to PL over IA. Then we would have the deformation is the integral of P dx over IA from the limit of 0 to L. So in here, the area is the product of the thickness and the depth, wherein y and t, if variable, must be expressed in terms of x. For the rod of unit mass ρ suspended vertically from one end, the total elongation due to its own weight, this is equal to density multiplied by the gravitational acceleration constant times L squared over 2e. And this is also equal to the mass multiplied by the gravitational acceleration constant, the L over 2ae. Where this ρ here is in kilogram per cubic meter, this is the density. L is the length of the rod in mm. And m is the total mass of the rod in kilogram. A is the cross-sectional area of the rod in mm squared. And g is the gravitational acceleration constant, which is equal to 9.81 meters per second square. So what is stiffness? Stiffness is the ratio of the steady force acting on the elastic body to the resulting displacement. It is the unit of Newton per meter. So we have the formula K is equal to P over the deformation.